Alright, problem number 1. Your final exam review. So you're given this triangle. This is angle B, angle A, and this is a right angle, side C, side A, side B. You're given that A equals 7, side B equals 5. Find angle C, find side C, angle A, and angle B. Okay. There are a lot of different ways that we can do this. Since this is a right angle here, you can use the Pythagorean theorem to solve for C. So a squared plus b squared equals c squared. So you have 7 squared plus 5 squared equals c squared, or 49 plus 25 equals c squared, or 74 equals c squared. So c, it's not going to be, I look down here at these answers and I see decimals, so it's not going to be a whole number. And it is a length, so we don't have to put plus or minus with our answer. So 74 square root. If you round to one place, that's 8.6. So just by solving for C, you can see I've gotten rid of a couple of my choices there. It's not going to be A and it's not going to be B. So I guess if you like to guess, you could do that now. But alright, so now let's solve for either A or B. It doesn't matter. And there's so many ways we can solve this now that we have all the tools that we have. But I'm just going to use what we learned, what we went over whenever we covered this section on 4.1. This is where this problem is from. I'm going to use the opposite and adjacent sides to this angle to help me solve for it. Remember, opposite over adjacent to an angle is tangent. So the tangent of A is equal to the opposite side over the adjacent side. So if you do that in your calculator, you say 7 divided by 5, and then do inverse tangent. So I think in those calculators you do secant tangent. That'll give you the angle measure. So 54.46. degrees. Alright, angle B, opposite over adjacent, is 5 over 7. So tangent of B is 5 over 7. So 5 divided by 7 equals alright, inverse tangent 35.54 approximately. Alright, so that's D. Number 2, find the exact value, if any, of the composite function. The sine of the inverse sine of negative 0.3. Alright, so as long as this is between negative 1 and 1, which it is, the answer is just this. So there's the answer, A. Number 3. Number 3 says the sine of theta is greater than 0 and the cosine of theta is less than 0. So we're trying to figure out which quadrant theta's in. So sine is positive here and here. Cosine is negative here and here. The quadrant where those overlap is where theta is. So where's theta? Quadrant 2. Number 4, the tangent of 10 degrees minus the cosine of 80 degrees over the cosine of 10 degrees. All right, this is a complementary angle theorem problem. Since this is 10 degrees and this is 10 degrees, what can I write the cosine of 80? What can I write that as in terms of, or with 10 degrees? 80 and 10 would be 90. But I need to change that now to what? Sine, right? Cofunctions. If you have cofunctions, if their angles add up to be 90 degrees, then they're equal. So instead of cosine of 80, I can write sine of 10. So I have sine of 10 degrees divided by cosine of 10 degrees. You can apply the quotient rule. And that's tangent 10 degrees. Tangent 10 degrees minus tangent 10 degrees. 0. Okay. Now the inverse tangent of the tangent of 5 pi over 7. Alright, the property that we have to go over, or we have to make sure that we understand, is if this angle measure here is between negative pi over 2 and pi over 2, if that is between those two, then the answer is just that. But it's not. 5 pi over 7 is not between negative pi over 2 and pi over 2. It may be easier for you to visualize if you think about that in degrees. So 5 times 180 divided by 7. So that's 128 degrees. 128 point something degrees. That's negative 90 degrees. That's 90 degrees. So this is definitely not between those two, since it was 128 point something degrees. So we need to figure out where is that located. Remember, this is 90 degrees here, this is 180 degrees here. That's negative 90 or 270. That's 0 or 360. So 128 degrees is here in the second quadrant. If the angle measure is here and the inverse function is only defined between here and here, I need to either change it to the one in the first or the fourth quadrant, depending on the positive or negative that goes with my angle measure, or my answer. So is tangent going to be positive or negative here? Tangent's going to be negative here, right? So since tangent's going to be negative here, then I need to change it to the quadrant where tangent is also negative, where it's defined. So that's going to be the fourth quadrant. So I want to take this angle measure and I want to put it down here. Okay? There's a couple of ways you could do that. The easiest way is probably not the way we're going to do it, but I can tell you the easiest way in just a second. But the way that we learned is by reference angles. So this angle over here is pi minus theta. This is theta. This is pi plus theta. This is 2 pi minus theta. Now, to put it down here in the fourth quadrant, I told you with inverse sine and inverse tangent, what you can do is if you figure out the one from the first quadrant, then just put a negative in front of it, and that'll move it to the fourth quadrant. And that works for inverse sine and inverse tangent. So if we do that, we're here, so let's figure out what is theta. What is the one from the first quadrant? What is the reference angle? We know that pi minus theta equals 5 pi over 7. So solve for theta. That's going to be negative 7 pi over 7, right? Pi is the same as negative 7 pi over 7. So I have negative theta equals, what do I get when I put 5 pi over 7 and negative 7 pi over 7? I get negative 2 pi over 7. So that's what negative theta equals. So what's theta going to equal? 2 pi over 7. Alright, so my reference angle is 2 pi over 7. To put it in the fourth quadrant, you just put a negative in front of it. So that's negative 2 pi over 7. That's what we want the angle measure to be. It's equivalent to that. Alright, so it'll be the inverse tangent of the tangent of negative 2 pi over 7, and now it's between negative pi over 2 and pi over 2. I mentioned this probably isn't the easiest way. I've never said this in this class when talking about this, but if you know that you have an angle measure in the second quadrant and you drew a straight angle has a measurement of pi. So if it's in the second quadrant and you want to put it in the fourth quadrant, all you have to do is subtract pi from it. That'll put it in the fourth quadrant. The reason why I don't teach it like that is because we don't always think about angle measures in the fourth quadrant as negative angle measures. We only think about negative angle measures with inverse functions. So all you have to do on this one is say 5 pi over 7 minus pi, and that's your answer. If you don't understand what I just said, that last part, don't worry about it, because that's not the way I teach it. The way I teach it is with reference angles and all the fun stuff. All right. Wait, that was number 5. All right. Yeah, I just didn't label it. That was number 5. This is number 6. Express the product as a sum. Alright, so this is a product to sum problem. Alright, so look at your formula sheet and look at the section that has product to sums. You should see like sine times sine. So sine of alpha times sine of beta, that's the formula we want to follow. It's equal to 1/2 times cosine of alpha minus beta minus cosine of alpha plus beta. Alright, so that's 1/2 times cosine of 3 theta minus cosine of 7 theta. Let's see. Number 7, find the area of the triangle. Alright, so if this side's 2, this side's 6, and this angle is 20 degrees, then the area is equal to 1/2 times the product of the two sides times the sine of the angle measure that they make. Alright, we'll do that in the calculator. That's 12 times 1/2, so 6 times 20 sine equals. Alright, so 2.05 square units if you rounded. Alright, number 8. The same directions. We have a triangle that has a side of 5, a side of 5, and a side of 4. So we have to use Heron's formula. That's 1/2 times S equals 1/2 times 5 plus 5 plus 4. So that's going to be 10, 14 divided by 2 is 7. So area is equal to the square root of S times S minus A times S minus B times S minus C. Alright, so that's the square root of 7 times 2 times 2 times 3. My answers are in decimals, so 7 times 2 times 2 times 3 is the square root of 84. 9.17 units if you round the two places. So 9.17 square units. Number 9, solve the equation on the interval from 0 to 2 pi. 2 times the cosine of theta plus 3 equals 2. So to solve for theta, you want to get cosine of theta by itself. So solve this, start out just like you would on a linear equation. So I've gotten cosine by itself. I get cosine of theta equals negative 1/2. Alright. So cosine is going to be negative in the second quadrant and in the third quadrant. So cosine is positive 1/2 at pi over 3. So if I want its multiple in the second quadrant, you say pi minus pi over 3, you get 2 pi over 3. If I want pi over 3's multiple in the third quadrant, you say pi plus pi over 3. You get 4 pi over 3. So your two answers are 2 pi over 3 and 4 pi over 3. Alright, number 10, 4 sine squared theta equals 1. Divide both sides by 4. You get sine squared theta equals 1/4. Take the square root of both sides. You get plus or minus the square root of 1 over the square root of 4 is 1 over 2. So sine of theta equals plus or minus 1 over 2, or 1/2. Alright, we know that sine is equal to positive 1/2 at pi over 6. So if I want the answer from, since it's plus or minus, I want the answer from every quadrant. I want all the positives and the negatives. So to get the angle measure in the second quadrant, you say pi minus pi over 6. That's 5 pi over 6. To get the angle measure in the third quadrant, you say pi plus pi over 6. That's 7 pi over 6. And to get the answer in the fourth quadrant, you say 2 pi minus pi over 6. That's 11 pi over 6. All right, so those 4 answers are your answers.
You said this is going to be, you already put this on Canvas, right?
All right, number 11, the directions say express the sum or difference as a product of sines and or cosines. So this is a difference. Cosine of 6 theta minus cosine of 2 theta. And I want to write that as a product. So you need to go to your formula sheet, go to the sum to product formulas, and look for cosine minus cosine. So cosine minus cosine, the formula sheet says that's -2 sine of alpha plus beta divided by 2. So alpha plus beta, there's alpha, there's beta. So that's going to be 8 theta divided by 2 times the sine of alpha minus beta divided by 2. So it's going to be 6 minus 2 is 4 theta divided by 2. Okay, so that's -2 sine of 4 theta times the sine of 2 theta. All right, so let's see. Number 12 is the tangent of the inverse cosine of -1/2. When the inverse is on the inside like this, you can use x, y, and r. So what you want to do first is you want to write over to the side. Cosine of theta is equal to x over r, which is also equal to -1/2. All right, so x is -1 and r is 2, right? I want to find the tangent of that. That's y over x. So I need y. Why, you may ask? To get my answer. Alright, so I use x squared plus y squared equals r squared. So -1 squared plus y squared equals 2 squared. So 1 plus y squared equals 4. So y squared equals 3. Take the square root of both sides. I get y equals plus or minus the square root of 3. Alright, so I need to figure out where would this inverse be located so I'll know whether to take a positive or a negative for my y. This is inverse cosine. Inverse cosine is defined between 0 and pi. Alright. Since I'm taking the inverse of a negative, it's got to come, the angle measure has to come from the second quadrant. In the second quadrant, x's are negative, which we've already found out, and y's are positive. So if we solve for y, we want a positive. And we did solve for y, so we want the positive square root of 3. So the answer is y over x. So a positive square root of 3 over a -1. So that's going to be negative square root of 3. All right. That's D. Number 13 is very similar, just different functions. The cosine of the inverse sine of 1/2. So I say the sine of theta equals 1/2 equals y over r. Y is 1, r is 2. Also, you could go ahead and say, we know that it's in the first quadrant because that's where inverse sine would be a positive 1/2 where it's defined. Alright? So, what do I need? I'm trying to find the cosine of that. And cosine is x over r. So I need to find x. When I find x, I need to make sure I make it positive. So x squared plus y squared equals r squared is your friend. Solve for x. So x squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4. So x squared equals 3. So x equals what? Plus or minus the square root of 3. But since we're in the first quadrant, we're going to use the positive one. Alright, so here's the answer. Cosine is x over r. So we're going to use the positive square root of 3 over 2. Number 14, the inverse sine of negative square root of 2 over 2. First of all, we know that inverse sine is defined between negative pi over 2 and pi over 2. So here and here. To find the inverse of a negative, we know that inverse of a negative is going to be down here in the fourth quadrant. But we want to write it as a negative angle measure. So the trick we can use with inverse sine and inverse tangent is that if we figure out the one from the first quadrant, then we can put a negative in front of it, and that'll put it in the fourth quadrant the way that we want it. So we say the sine of what is the square root of 2 over 2? Alright, that's pi over 4. So put it in the fourth quadrant, just put a negative in front of it. So the answer is negative pi over 4.
And those use a reference angle?
I'm not using the reference angle because if you do the reference angle chart, it's going to write it as a positive angle measure. So if you do use the reference angle chart and you get the positive angle measure, then you have to subtract 2 pi from it to put it in that place. That's the reference angle chart that you're talking about.
That's right.
If I use that, you can use that, but your answer you get will be 7 pi over 4, which is not the answer, because the inverse functions are defined in specific places, and inverse tangent is defined between negative pi over 2 and pi over 2. So if you have an answer in the fourth quadrant, you have to write it as a negative angle. But I told you that as a shortcut for inverse sine and inverse tangent, if you need an answer in the fourth quadrant and you figure out the one from the first quadrant, you can just put a negative in front of the angle measure and that'll move it to the fourth quadrant. That's because of the even-odd properties that you can do that. Alright. Number 15, y equals 2 tangent of 4x. Graph y equals 2 tangent 4x. Okay? So the two things that we are concerned with when graphing tangent are where do we cross the x-axis and where is the function undefined. Okay. So I told you that tangent always crosses at 0 regardless of what's in front here. If you plug in a 0, you're taking the tangent of 0. Tangent is sine over cosine, so that's sine of 0 is 0, cosine of 0 is 1, so that's how you get tangent of 0. 0 divided by 1, 0. Alright, so we know we are going to always cross at x equals 0. Now, where is this undefined? There's two ways to do this. Either you write down all the places where it crosses and find the midpoint of all of those. Any two consecutive places where this graph crosses, if you find the midpoint of the two x values, that is where you will have a vertical asymptote. Or, if you remember one place that it crosses, like I always remember that the tangent of pi over 2 is undefined, then I can figure out one place where it crosses by saying 4x equals pi over 2 and solving for x. So if I do that, I know that at x equals pi over 8, I'm going to have a vertical asymptote for this particular function. Okay? So again, though, there's two ways to do that. Either you get the midpoints of the places where this crosses, or you figure it out knowing one place and you can find one place. The reason why we only need to know one place is because we use the period to find other places with tangent and cotangent. The period for tangent is equal to pi divided by omega. So here, the period is equal to pi divided by 4. So if I know one place that I cross, I know that if I add pi over 4 to that, or I subtract pi over 4 from that, that's going to be other places where you also cross. Now, I told you there was another way to find where you're undefined. You take the midpoint of any two consecutive x values, so add those two together and divide by 2, and you'll get a place where you have a vertical asymptote. Well, if you do that, you get pi over 8, which is the same answer that we got when I solved this little fancy equation here, pi over 8. So we know we have a vertical asymptote there. Then using the period, you can find other places, or just find the midpoint between other points where you know you cross. But if I wanted one over here, you'd have to say pi over 8 plus pi over 4. That would be 3 pi over 8. Alright, same here. If I have negative pi over 4 and I subtract, negative pi over 8 and I subtract pi over 4, that's going to give me negative 3 pi over 8. Alright, and tangent goes up and to the right, down and to the left. The 2 in front is just going to make it increase and decrease faster, so the graph will not have as much of a bow in it. Now, if you look at your answers, you see two answers there that hardly have any graph. I mean, they have two little pieces of graphs. Then you see some that have lots of graphs. Right away, you can cancel A and B. It's not going to be one of those with not very many graphs. So it's either got to be C or D. So what you do is you check all the places where you cross on the graph given, check all the places where you cross here, and just match them up. Okay? And if you do that, then you can see that you should get D on this one. Number 16, y equals 2 secant of 1/3 x. When graphing secant, we actually want to first graph cosine. Okay? And remember, when graphing sine, cosine, secant, and cosecant, we have to know the period, the subintervals, and all that kind of fun stuff. The amplitude. So the amplitude for this graph is the absolute value of 2, which is 2. The period for this graph is equal to 2 pi divided by omega. What is omega? 1/3. So the period, if you flip and multiply, that's going to give you 6 pi. So one complete interval is from 0 to 6 pi. Now we don't have a phase shift. There wasn't any minus stuff out here, so we don't have to worry about phase shift. So I am going to create 4 subintervals. We're going to start at 0 and we're going to end at 6 pi. Alright, so what are we going to have to do? We figure out the period, divide that by 4. So period divided by 4, that's going to be 3 pi over 2. This is the value that I add to the first significant point to get the next significant point. And then so on and so forth. And I should end at 6 pi. If I don't, I messed up somewhere. So the number here is 0 plus 3/2 pi, or 3 pi over 2. Gives you 3 pi over 2. Then you write that value again in the next subinterval. Then add 3 pi over 2 to that again. So that will be 6 pi over 2. 6 pi over 2 is 3 pi. Remember, that was 6 pi over 2. That might help you because you have to add 3 pi over 2 again. That would be 9 pi over 2. Add 3 pi over 2 again, and you get 6 pi. You get 12 pi over 2, which is 6 pi. Alright, so I'm going to use those key points to help me graph this. My amplitude was 2, so that means my high point's going to be 2, my low point's going to be -2. My significant points, 0 is my first point, and my next point is 3 pi over 2. My next point is 3 pi. My next point is 9 pi over 2. And my last point here is 6 pi. Remember, cosine, and we're graphing cosine here. We're not graphing secant. Cosine starts at a high point, then we cross, then we have a low point, then we cross, we end up at a high point. So, like that. Now, any place that you cross, you put a vertical asymptote. And so now we can graph y equals 2 secant 1/3 x. So anywhere that you have a high point, you draw a U-shaped graph opening upward. Anywhere that you have a low point, you draw a U-shaped graph opening downward. So the blue graph that I have up here, that's secant. And so what you want to do is you want to kind of match the graph up that we have and what they have and see which one is the closest. It's either C or D, but then if you look really close, I have this U-shaped graph opening downward. If you look right above that, that's at 3 pi. And so that's the same as D. You see that there's one opening downward at 3 pi as well, but you don't have that on C. It's opening downward at 2 pi on C. So it's got to be D there. Okay. All right, number 17. Without graphing, find the period. Y equals cosine 5x. So this is something you have to do to graph anyway, and we just got through with the graphing problem. So it's 2 pi divided by omega. So 2 pi divided by what? 5. There's the period. If you missed that one, Trig is taught every semester. I can't help you. Unfortunately, you take it here at Colin, I'm the only one doing that right now. So, number 18, find the amplitude. Amplitude is the absolute value of the number in front of the function. So it's 2. Done. All right. Number 19. Sine of theta equals 1/4. Theta is between 0 and pi over 2. Find the sine of theta over 2. So that's the half angle formula. So that's plus or minus the square root of 1 minus cosine theta over 2. Alright, so with this given information, since theta is in the first quadrant, theta over 2 is also going to be in the first quadrant. Alright, so it's going to be positive. We're not given cosine, we're given sine. So if we use x, y, and r, then we can solve for sine of theta. I mean cosine of theta. We have sine. So remember, that's y over r. I need to solve for x because cosine is x over r. So I need cosine theta. Alright, so x squared plus y squared, which is 1 squared, equals 4 squared, which is 16. So x squared equals 15. So x equals what? And it's plus or minus, but since we're in the first quadrant, it's positive. So cosine is the square root of 15 over, what was r? 4. This is what we plug into our formula for cosine theta. So 1 minus the cosine of, no, we know what cosine is equal to. 1 minus square root of 15 over 4 all over 2. Now what can I multiply times the numerator and denominator? If I multiply the numerator and denominator by 8, that's going to make it where I can take the square root of the denominator. So this is the square root of, multiply this 8 times both of those. So that's going to be 8 minus 8 square root of 15 over 4. 8 square root of 15 over 4. That's 2 square root of 15. And then I told you on the bottom we're going to have the square root of 16. That's what? 4. So the answer is C. Alright, problem number 20. Cosine of theta equals 12 over 13. Theta is between 3 pi over 2 and 2 pi. Find the sine of 2 theta. We only have one formula for the sine of 2 theta. That is 2 times the sine of theta times the cosine of theta. So to find the sine of 2 theta, you need sine theta and cosine theta. I was given cosine theta. So I need to find sine theta. So remember, cosine is x over r. Which quadrant are we in? What quadrant is this? Alright, that's fourth quadrant. In the fourth quadrant, x's are positive, y's are negative. So to find sine of theta, I'm going to need a y. And so when I find y, it's going to have to make it negative. So x squared plus y squared equals r squared, just like we've done so many times before. Alright, so 144 plus y squared equals 169. So subtract 144 from both sides, and you get y squared equals 25. So take the square root of both sides, so y equals plus or minus 5. Now since I'm in the fourth quadrant, I need the negative. All right, so y here is going to be negative 5. So what is sine of theta going to be for my formula? It's y over r. So that's negative 5 over, what was r? 13. All right, so now that's what I plug in right there for sine. I plug in 12 over 13 for cosine. So 2 times negative 5 over 13 times 12 over 13. Okay, multiply all the numerators together. So that's, well, that's negative 10 times 12 is negative 120 over 13 times 13 is 169. There's your answer. All right, that's number 20. Number 21, the sine of theta equals 1/4. The cosine of theta equals square root of 15 over 4. Find the secant of theta. This is one of those problems where you're given a little too much information. You don't need all that. Not to solve for secant. Remember, secant is 1 divided by cosine. So if we take the answer for cosine and flip it, we have the answer for secant. So in this problem, that's equal to 4 over the square root of 15. Then rationalize. So that's 4 square roots of 15 over 15. That's the answer. Number 22. Convert the angle measure in radians to degrees. Pi divided by 5. How do you convert that to degrees? 180 degrees divided by 5. All right, so 36 degrees. All right, that's it. Number 23. Use the fact that the trig functions are periodic to find the exact value of the expression. Do not use a calculator. The sine of 405 degrees. If an angle measure is greater than 360, we can subtract 360 degrees from that. And the answers that we get for the sine of 45 degrees will be the same for the sine of 405 degrees. The sine of 45 degrees, we all know, is the square root of 2 over 2. So that's the answer. All right. Number 24. Find, it's to use the fact that the trig functions are periodic. That's what I just did. Find the exact value. Do not use a calculator. Tangent of 0. We've already done that once when we were graphing earlier. Tangent of 0 is equal to 0. There's the answer. Can't make it any easier than that. Well, I guess we could. Here's an easy one. The sine of 2 pi. Remember, the sine of 2 pi is the same as the sine of 0. The sine of 0 is 0. Number 26, solve the triangle. So I have, this is 20 degrees, this is 125 degrees, this is side C, this is side A, this is angle C, and this is that would make this side B, and it's equal to 3. Alright, so since I know a corresponding side and angle, you can right away just jump into law of sines if you want. But you can see that you can easily solve for angle C there. So if you said 180 degrees minus 20 degrees minus 125 degrees, then you would get what? 35 degrees. And if you look down at your answers, that already eliminates 2 of them. So, I mean, that's just a quick way to get rid of 2 answers. Anyway, so if I use the law of sines, I'm going to use the proportion the sine of 20 degrees over 3, because that is a corresponding angle and side that I know for sure. Now I need to look at other corresponding angles and sides and set up proportions. So I'm going to set up this proportion. Sine of equals the sine of 125 over A. Now solve for A. Cross multiply. So that's going to be A times the sine of 20 degrees equals 3 times the sine of 125 degrees. Divide both sides by the sine of 20 degrees. Make sure that your calculator's in degree mode, and you'll say 3 times 125 sine divided by, you may want to hit equals first, then divided by sine of 20 equals. Alright, so I got, if you run it at 2 places, 7.19. Now, by the process of elimination, if you look down there, there's only one answer that has angle C equals 35 degrees and side A equals 7.19. Alright, and that's D. That's the only one that has those 2. So you could stop there. The answer is D. To save time, I am going to stop there. If you wanted to, though, you could come back and solve for side C the same way that we solved for side A, by setting up this proportion equal to the sine of 35 degrees over C. Alright. Alright, so if we want to solve this triangle, I'm given that B equals 3, A equals 25, and angle B is equal to 104 degrees. Alright, so I want to solve for the sides that I don't have. I do have a corresponding angle here with a side, so I can use the law of sines. So that is the sine of 104 over 3. I'm going to use that to help me solve for, looks like I'm going to start out and solve for angle A here. So that equals the sine of angle A over 25. Okay. So cross multiply and divide. You get 25 times the sine of 104 degrees equals 3 times the sine of A, and divide both sides by 3. Alright, so it's going to be 25 times the sine of 104 degrees divided by 3. And then to find A, you hit inverse sine, and you can see I have an error. That means there's no triangle. So this actually wouldn't work out with these numbers. Alright, so my answer is D, no triangle. Number 28 says solve the triangle. So we're told this is side is 3, it's 25 degrees, this is 10, this is angle C, side B, angle A. Alright, so the first thing that I notice is that I do not have a corresponding side and angle that I know. So since I don't have a corresponding angle and side, I am going to have to use the law of cosines. Alright, so the first thing you do with the law of cosines is you want to solve for the side you don't know. So that's going to be b squared. So b squared equals a squared plus c squared minus 2ac cosine of angle B. Alright, so that's going to be b squared equals, so that's side A, that's side B, no, sorry, that's side C, alright, so 3 squared plus 10 squared minus 2 times 3 times 10 times the cosine of 25 degrees. So b squared equals, that's going to be 9 plus 100 minus, that's going to be 60 cosine 25 degrees. Alright, so I have 109 minus 60 cosine 25 degrees. I'll do that in a calculator. And remember, that's what b squared equals. So I do need to take the square root of both sides. So 109 minus 60 times 25 cosine equals, alright, and so I have to take the square root of that. That should give me b. So b is equal to, and I'm going to write this out because I'm going to have to use b in another formula. We can round this to whatever we need to round it to, but keep in mind that if we do have to use it in another formula, that we want to try to keep it a little exact, a little more exact. So I get b equals 7.39, and then I'm going to carry it out a couple more places. 0.638. Okay, so that means that, you know, on my paper it may be 7.39 or 7.4. I just have to look and see what they want, or what they have. Looks like 7.39 is the winner on that one. But I want to use that longer decimal when if I have to use it in a formula. Alright, so now it makes most sense to either solve for A or C here. I'm going to solve for A. So cosine of A equals, and remember the formula. It is on the formula sheet. You don't have to remember it, but look at the formula. That's going to be b squared plus c squared minus a squared all over 2bc times the cosine, oh, we've already solved, sorry, 2bc. So that's it. So that's what we want to use whenever we solve for the cosine of angle A. So just plug in your numbers. Remember, for B, I'm plugging in 7.390638. So that's plus 10 squared minus 3 squared all over 2 times 7.390638 times 10. Alright. So 7.390638 squared plus 10 squared is 100 minus 3 squared is 9. Alright, and then you can divide by this, and divide by this. So divided by 2 equals, divided by 10 equals, divided by 7.390638 equals. So that's what the cosine of A is equal to. Alright, so since that's what cosine of A equals, then we need to say inverse cosine. Okay, and I got 9.877. So on your test they round angle measures to one place, so that would be 9.9 degrees. Alright, now I have two of the angles, so I can solve for the third. So angle C is equal to 180 degrees minus 25 degrees minus 9.9 degrees. Alright, so and that's 145.1 degrees. That is an approximation, but that's what your test is looking for. Okay. Number 29. We have a triangle where this side is 5. This angle measure up here is 105 degrees. This is 6. This is angle B. This is side C. This is angle A. That means this is side A. This is angle C up here, and that would make this side B. Alright, so it looks like this is very similar to the last problem. So all I'm going to do is I'm going to use the law of cosines because I don't have a side and an angle that I know. So I'm going to solve for side C first. So that's C squared equals A squared plus B squared minus 2AB cosine of angle C. So that's going to be 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of 105 degrees. Alright, so that's, I could do that in a calculator. That's 25 plus 36, so that's these two numbers. Then minus, alright, that's going to be 60 there, so minus 60 times 105 cosine equals. So that's what C squared is equal to. So if I want C, I need to take the square root of that. So the square root of that, and I'm going to carry this out a couple of places, 8.74809. 74809. Okay, and so on your test they're probably going to round that to two places, so you're looking at about 8.75 on your test. That's what you'll be looking for. Alright, so we're going to use that to find some other stuff. That's why I'm going to keep it that long again. So I'm going to solve for angle A next. The cosine of angle A is equal to B squared plus C squared minus A squared all over 2BC. Alright, so plug those values in. So 6 squared plus 8.74809 squared minus 5 squared over 2 times 6 times 8.74809. And that's what the cosine of angle A is equal to. Alright. So we'll punch this in the calculator. It's 36 plus 8.74809 squared equals minus 25 equals. So that's the numerator. And it's going to be divided by 2, divided by 6, divided by 8.74809. And so then I say, that's what cosine of A equals. So I say inverse cosine, and I get 33.5 if I round to one place, like your test does, 33.5 degrees. So angle A is about 33.5 degrees. So angle B can be solved by saying 180 degrees minus 105 degrees minus 33.5 degrees. So 180 minus 105 minus 33.5. It's 41.5 degrees. Okay. Moving on to the next problem, which is the last problem of the test, number 30. This is a side-side-side triangle. So you have all the sides. This is angle B, this is angle C, this is angle A. And so what we need to do is we need to solve for two of those angles using the law of cosines, and then we'll figure out the third angle because all three angles have to add up to be 180 degrees. Okay? So it doesn't matter which angle we start with. I'm going to start with cosine of angle A. Alright, and we know that that's equal to b squared plus c squared minus a squared all over 2bc. Okay, so that's what I'm going to plug in. So I'm going to label my sides to make sure that I don't make a mistake. It's good to take the time to do that. So that's 6 squared plus 8 squared minus 7 squared over 2 times 6 times 8. Alright. So that's going to be 36 plus 64 minus 49. So that's 51. Alright. And so now what I can do in my calculator, I can just take and divide by 2 equals, divide by 6 equals, divided by 8 equals. And that's what the cosine of A is equal to. So to get the actual angle measure, you say inverse cosine. And if we round that to one place, that's 57.9 degrees. So angle A is about 57.9 degrees. Alright. So now what we do is we can either solve for angle B or we can solve for angle C. Now it doesn't really matter which angle you solve for. I usually just go with the next letter. So I'm going to solve for angle B. And so the formula that I'll use to solve for angle B is the cosine of angle B equals a squared plus c squared minus b squared over 2 times a times c. Alright, so a is 7, so that's 7 squared plus c is 8, so that's 8 squared minus minus b is 6, 6 squared over 2 times a is 7 times c is 8. Okay, so that's equal to, and I'll use the calculator to do that really quick. So that's 49 plus 64 minus 36 divided by 2 equals, divided by 7 equals, divided by 8 equals, and so that's what the cosine of angle B is equal to. So I'll say inverse cosine, and if I rounded that to one place, that would be 46.6 degrees. So that's not equal to, angle B is about 46.6 degrees. Now, to find angle C, I'll simply say 180 degrees minus A, angle A, which is 57.9 degrees, minus B, which is 46.6 degrees. Okay? So, do that in a calculator to do it really quick. So 180 minus 57.9 minus 46.6, and I have 75.5. So angle C is about 75.5 degrees.